What are you doing?
In part A,
Which problem is it, Robert?
1985
write that thing.
electromagnetic tube, right up here.
83% tested, nope. 86% tested, wow.
As you can see, we're using this circuit here just in case you didn't know. Part A is calculate the current I initial immediately after the switch is closed. So, very initially, you're going to use the equation V equals IR, which relates the voltage to the resistance to the current of circuit Ohm's law.
Did you understand?
So the voltage is going to be 3,000 volts. And initially, your resistance is only going to be 5 times 10 to the 5th ohms.
That is not moving behavior. That's not noise.
I can see what you're doing on the board also.
Okay. Now that these guys are out of the way. So you're going to get 3,000 equals 5 times
It's not that funny.
10 to the 5th
Maybe it's funny because it's on camera.
I.
Zoom in
So
on
you're
Ravi's
going to
butt.
divide both sides of the
That's
equation by
The
5.
big booty pictures right there.
We get a chair. Oh, that's bad.
I'll go back. I don't want to mess up the video.
Divide by
I
5.
already did. I don't want to mess up
And
anymore.
your I is going to equal
You have to use like
point
Sony Vegas Pro to edit out the notes.
0.0006 amps. Okay. Part B. On the axis below, sketch the potential difference V2, which is the potential difference across the resistance 2, so we'll have a little V2 right there, as a function of time. So when it starts off, there is no potential difference here because the switch is closed. So you're going to start at 0, and it's going to grow, as the switch is closed, it's going to grow exponentially until it reaches its asymptote, until it reaches its max. So it's going to look something like this. And it's going to go on forever, as long as the switch is there. Now, then we'll go here for part C. Calculate the current I2, which is, that's right that, you're right there, after the switch is closed. It's going to be the same equation, V equals IR. The voltage is still going to remain the same because it's being powered by the same power supply. But now your resistance is going to change because it's going to flow through this resistor. So you're going to have two resistors of 5 times 10 to the 5th ohms and 10 times 10 to the 5th ohms equals total resistance of 15 times 10 to the 5th ohms.
It's like 2 to the end. You just plug in 1, 2, 3, 4.
So then if you plug into the equation, then you get I equals 3,000 over 15 times 10 to the 15th. And you're going to get I equals 0.02 or 0.002 amps. Part D is calculate the charge Q on the capacitor. You can use the equation Q equals C times the change in voltage. You know your C is 5 microfarads, but because it's microfarads, it's going to be 5 times 10 to the negative 6th equals your C. The change in V is going to equal 2,000 volts. And when you plug those in, you're going to get Q equals 5 times 10 to the negative 6 times 2,000. You get Q, which is the charge on the capacitor, equals 0.01.
Units.
Now, calculate the energy
Ravi,
stored.
the units.
I'm gonna get that.
Oh, my bad. Q is coulombs.
The U, micro. You need the micro.
Micro coulombs.
I'm gonna use movie maker and
Okay. Part E is calculating the energy stored in the capacitor, and for that you can use U equals 1/2 CV. You know your C is 5 times 5 microfarads, and your voltage, which we used, was 2000, and you're gonna get 1/2. So basically 1/2 times those equals your U. So your U is going to equal 5,000 microfarads, or you can change it and write it as 0.05 farads. Either way. Now, switch S is opened. Part F. On the axis below, sketch the current I2 as a function of time and clearly indicate the initial and final values. Because the switch S is opened, it's no longer receiving energy from the battery, but it's going to have to get all its energy from the capacitor.
how to place it here. What?
The current, there's going to be initial current because as soon as it's opened, it's still going to have voltage flowing from there. It's going to start down here, but it's going to get closer to 0 as the capacitor uses all its charge. It's going to get exponentially closer to 0. And will eventually get very, very close to 0. Basically 0 since that's.
I got that like.
Okay, that's it.